Welcome to the Gate Academy. So in this session, beta, we are going to see the memory-based questions solution of GATE 2021 civil engineering examination for the subject of strength of material. Okay. So in this session, beta, we will be solving strength of material memory-based questions. Memory-based questions. So I again welcome you to the GATE Academy. So in this session, we'll be solving the memory-based question of strength of material. So let's begin. Let's begin with solving the memory-based questions. So let's begin. Okay. This is the question of strength of material that has been asked in GATE 2021 Civil Engineering. That has been asked in GATE 2021 Civil Engineering. So let's read the question first. So for the beam shown, find the deflection at point B. What we have to do, we have to find the deflection at point B. And where is this point B? So this point was given to be A, this is B, and this is C. Okay. So we can see in this question that a load of 100 kilonewton is applied vertically on point B. So in this question, we need to find what? We need to find the deflection at point B due to this load. We need to find the deflection at point B due to this load. So we can solve this question by any method. So this question, as we can see, belongs to the chapter of deflection. It belongs to the chapter of deflection, right? And how it is different from the previously asked questions, previous year GATE questions. So in this question, we can see that our EI is not constant. What is EI? EI is fluctual rigidity as we know it. So here we can see that EI is not constant, and EI is given to us. So here it is given to be EI, and here it is given to be 2EI. Getting my point? So what is here in this a simply supported beam, you can see on the screen. So in this simply supported beam, the EI is not constant. Normally in simply supported beam, the questions that normally asked to us in that EI is given to be constant. But here in this question, EI is not constant. And now how to solve this question? You guys can tell me in the comment section how we can solve this question, what method to apply in this question. So we know we have several methods. We have double integration, we have area moment method, we have conjugate beam method, we have strain energy method. So we can solve it by any method, but I would choose the strain energy method, because I think from strain energy method we can easily solve this question. Okay, so it is a simply supported beam. We can see that this beam is loaded at the center. So we know when a simply supported beam is loaded at the center, that is symmetrically loaded, the reaction is equal and half of the net loading. So can I say it is P by 2 and it is P by 2? Okay. You can tell me in the comment section if we have a problem in this. So we have load is equal to half of the net loading when the support is simply supported, or when the beam is simply supported beam. So we have the reactions equal to P by 2 and P by 2. We have the reactions equal to P by 2 and P by 2. Now, from strain energy method, we know how to find the deflection by strain energy method. So we know to find the deflection by strain energy method, we need to, or we can say by Castigliano theorem. We know strain energy method is also known as Castigliano theorem. So what we can do, we can firstly find the strain energy of this beam. And then we can partially differentiate it with the load at point B. And if we do it, we'll be finding the deflection at B. Now, sir, how to find the strain energy? So if I make the bending moment diagram of it, so I am sure all of us can make it. So if I make the bending moment diagram of it, it will be like this: PL by 4 at the center. Yes or no? So I can see that there is two variations. The bending moment diagram has got two variation, that is variation 1 and that is variation 2. So what we can say? We can say that our strain energy would be U1 plus U2. Our strain energy will be U1 plus U2, isn't it? The strain energy of this first section, let's say AB, and the second section, let's say BC. The second section, let's say BC. So if EI is not varying, if EI is not changing, we could have said that U1 and U2 are same only. But in this case, U1 and U2 are not same because EI is changing. Because EI is changing, so what we can do, we can follow the same process as we do to find the strain energy, and let's consider a section X here. Let's consider a section X here. So we know how to find the strain energy. We know how to find the strain energy, how we can find it, what is the general relation. So we can see that this variation is from 0 to L by 2. So let's see, let's write the load at X section. So we know our strain energy is what? Strain energy is given by this relation, isn't it? Strain energy is given by this relation in general, but here we can see that our EI is 2EI. Our EI is 2EI. So we can write it like this. So now if I place the value of Px, what the value of Px would be? So it is 0 to L by 2. So this is Px. So this is P by 2 into X. If I take P at that section, M at that section, so this is M because we are seeing the beam. So if we see the M at that section, so it will be like this. It will be 4EI. So if I integrate this in this limit, it will be P square by 4. Now I think all of us can integrate it. So if I integrate this, so this will become P square by 4 and this will become X square integrated to X cube by 3. So if I place the value, it will be L by 2 whole cube by 3, isn't it? X cube by 3. So I am placing the limit from 0 to L by 2. I am placing the limit from 0 to L by 2, and this will be 4EI. This will be 4EI. So let's say what U1 we are getting from here. Let's see what U1 we are getting from here. So what U1 we are getting from here, so this will become P square. It will become L cube. So this will be 8 into 4 into 3 into 4. So let's calculate it. 8 into 4 into 3 into 4. So I am getting 384. So we'll be having U1 is equal to P square L cube upon 384 EI. 384 EI. Now, in order to find U2, what we can do, we can take section from right hand side now. In the same way, we can take section from right hand side now, and we can take the moment, So if I take the limits now, so it will be 0 to L by 2. So I shall write the moment at that X section. Okay, this is the general way of finding the strain energy. Now here EI is EI only. Okay, so what changed happened in the first, while I solve for U1, I put it here 2EI, but here I have to put EI because I can see the fluxural rigidity of this BC section is EI only. The fluxural rigidity of this EI section of this BC section is EI only. Now again if I place the value, so it is 0 to L by 2. What moment I'll be getting from there? So I'll be getting P by 2 X whole of square dx upon 2EI. So if I now integrate it, so I'll be getting what? I'll be getting P square 4, okay, P square by 4 again, okay, I have squared this P by 2, so this is X square. So if I integrate it again, I'll be getting L by 2 whole cube, L by 2 whole cube into 1 by 3, and this will become 1 by 2 EI. This will become 1 by 2 EI. So what I'll be getting? What I'll be getting? So I'll be getting here. So this will be P square L cube. Now here 4 into 8 into 3 into 2. Now let's again calculate it. Or you may say, sir, why not be half the above value? So you can do that also. It depends upon the aptitude. So I am doing it in the most easiest way. Okay, so we can see our U2. Now, can we get the complete strain energy of this beam? Can we get the complete strain energy of this beam? Yes, sir, certainly we can. So what is the complete strain energy of this beam? So if I calculate the complete strain energy, so I must add U1 plus U2. So I see that this P square L cube upon EI is common only, and this will be 1 upon 384 plus 1 upon 192, 1 upon 384 plus 1 upon 192. Now let's do it with the use of calculator. So if I find it, I am getting 1 by 128. So what is the net strain energy? What is the net strain energy we are getting from here? What is the net strain energy we are getting from here? We are getting P square L cube EI by 128. So this is the net strain energy we are getting from here. Now, what will be the deflection at B? So we know that if we have the strain energy, we can differentiate it. We can differentiate it with respect to the load acting at that point. So if I differentiate it with P, I'll be getting what? I'll be getting. So if I differentiate it with respect to P, I'll be getting PL cube by 64 EI. PL cube by 64 EI. Okay, so this will be the deflection at B. This will be the deflection at B. So if we have any doubt, you can ask me in the comment section. You can ask me in the comment section, and you can share this video with your friends so that all of your friends may come to know how we can solve this question very easily. Okay, very easily. Many would choose to solve this question with conjugate beam method, but I feel that will be difficult. Okay, comparatively difficult. So we can do it very easily by strain energy method. Now, if we have the formula, I know that we can put the values here. We can put the values here to solve the question. We can put the values here to solve the question. So if I place the values here, so what is my P? It is 100 kilonewton. So this is 100 into 10 to the power 3. What is my L? So this is 8 meter. This is 8 meters. So don't forget to change the unit to mm. So this is 64. What is our E here, beta? What is our E? So E is 3 into 10 to the power 4 megapascal. So the unit is Newton per mm square. No need of changing it. No need of changing it. And what is I given to us? I is 225 into 10 to the power 6. 225 into 10 to the power 6. So if we solve this, we will be getting the deflection at B. So you can tell me in the comment section, beta, what are we getting? You can tell me in the comment section, what are we getting from here? What are we getting from here? So let me calculate with you guys only. Let me calculate with you guys only. So from this, we are getting 118.5 mm. 118.5 mm. This is the deflection of this point B. This is the deflection of this point B. Understood, beta? Understood. So, beta, this is how we can solve. This is how we can solve this question. This is how we can solve this question. This is how we can solve this question here. All right. This is how we can solve this question. So, beta, do not forget to share and subscribe the Gate Academy channel. Do not forget to like the video. Okay, and I am very sure that this video is helpful for you. So please like and share the video. And for any doubts, feel free to comment and to contact us. All right. So thank you very, very much. Okay. Thank you very, very much.